Hello, tech enthusiasts. Welcome back to Tech Crux. You're turning into the second part of our customer review analysis project. So, last time we dived into web scraping, extracting new raw data from the depths of the internet. Today, we roll up our sleeves for the crucial next step, data preprocessing. So, are you guys ready to turn our raw data into a treasure of insights with me? In data science, preprocessing is like preparing your ingredients before cooking a meal. It's all about cleaning, organizing, and transforming your data. Without this, even the best algorithms can't uncover the true flavors hidden within your data. For NLP, the most common pre-processing techniques are tokenization, lemmatization, stop words removal, etc. Some of which I will give you a first-hand experience to you in this video. So all of our machine learning models are basically data driven. The data determines how good the algorithm or the model is going to perform. Even though you choose the state of the art model, even if your data is not properly pre-processed, the model will not perform very good. And if the data is really good, then even the lowest performing models can outperform the state of the art algorithms working on bad data set. So why do we go through all these steps? So think of it as cleaning and organizing your room before throwing a grand party. It makes it easier for guests, in our case, the NLP algorithms, to move around and find what they need. Let's walk through the Python script that turns our jumbled data into a clear, structured format. So as you can see, we start by bringing in our tools. Pandas for data structure and data frame magic, and NLTK, a powerful Python library widely used for NLP tasks. When you use these libraries for the first time though, to perform some functions, you might have to download some more packages, which I have mentioned here. It's possible that I might have missed a package here, so you can improvise it later onwards when you're actually running the code yourselves. Since I've already downloaded these packages, you see that for all the package it is saying it the particular package is already up to date, but you will have to download them if you're using them for the first time. So once all the setup is done, we will load our dataset which we extracted in the last video. I'll quickly load the dataset and show you so that you can remember what dataset that we had that we were using in the last that we extracted in the last video. So this is the Flipkart Lenovo Legion product dataset. There are multiple products here with different prices. We have a ratings column, number of ratings, number of reviews, a review summary, and the review details. So currently, as you can see, for each product there is a single row. Every row depicts a different product, and we have a total of 10 products here. You can see for the first product in the review summary there are multiple reviews, and in review details as well there will be multiple reviews. So what we'll have to do is we'll have to split these into different rows so that the model can analyze this better. You can see that we have some no rating available, some nan values, some has zero reviews. Again, we have nan values here, which we'll be dealing with in this particular video. Just like patching up holes in a dress, we add in some dummy data to replace missing values. This ensures our dataset is complete, giving us a fuller picture. So here we are creating dummy reviews for some products to fill nan values. I will run this code, which will add some dummy reviews in the second and the fifth index. Second index will be this one, and the fifth index will be this one. So after which I'll again print the data frame, so you can see that we have added some reviews in the second one, and in the this was the second and this was the fifth. You see before it was none and now there are some values present. As we did not fill all the null values, we remove the leftover ones so that there is consistency in our data. We remove these two rows so that we only have those rows which have data inside them. This particular step will do that. You can also clearly see that we have columns such as review summary and review details, which contains multiple reviews for each product, right? As I showed when I first imported this data set. It will be convenient for our model to read the data if we can split this into separate rows. These columns contain string representation of lists. So the first part of the code converts these string representations into actual Python list objects. This is done using the AST literal eval method. So you see we're applying this particular method on these two columns. So once these have been converted into Python list objects, we will then use the explode method which takes each element of the list in each row and turns it into a separate row. This is done to ensure that each review summary and detail is in its own row. So after which we perform some more data cleaning for better results. So you see we have used explode function here. I'll quickly run this cell, after which I will show you what the new data frame looks like. So now the data frame size has increased, and you can see for each particular product there are multiple rows, each row depicting a single review and their details. So for some products which have multiple reviews, this step has been done, and now the data set which was only of 10 rows is now of around 43 rows. After we have played around with the data frame as much as we wanted, now we'll peek into the shape and structure of our data set. This is like reading a map before starting a treasure hunt, so that we know which techniques will be most useful for us. So I will run this step, and we have the final data set with us. Let us now see what all we can do using the NLTK library, which is essential for NLP tasks. This will lay the groundwork and help you better understand how the models will be working on our dataset. First comes tokenization. In this step, we chop up text into bite-sized pieces, words or sentences. This makes it very easy for our algorithms to digest the information. So you see that I'm taking the review details of the first index and I'm printing it, and we see that this is the overall overall the product is really nice, blah blah blah, whatever the review had written in it. Then we perform the tokenization step. So I will put the tokens into a variable and call it tokens, and I will print it out for you. You can see the whole sentence is split so by each word, and this is not just a direct split based on the spaces. This is actually a smart split, and the basic purpose of it is so that the model can learn better through the tokens rather than inputting the model the whole sentence. After this, we perform part of speech tagging using the POS tag function. It understands the role of each word in a sentence. Is it an action, a description, or an object? So I'll quickly run this for you guys as well. You see, for each token that we separated in the last step, it is showing if it is an adjective, if it is a noun, or what kind of an object it is. So this is where we tag each word with its grammatical role, laying the groundwork for deeper analysis. It detects nouns, adjectives, verbs, and a lot more. Search for the POS tag list and see what all these particular tags mean. So we have JJ, which means a large adjective. Then we have NN, which is a noun, and all of these are essential when you're building a model of your own and you want to perform some NLP task on it. Another important pre-processing technique used widely in NLP projects is stopword removal. So you can consider the stopword removal as like removing too much chatter from a conversation. So stopwords are those common but unnecessary words like and, the, or, is. Removing them helps us focus on the words that matter. So this generally helps when the data set is huge and the context of data does not matter much. I will run this cell as well so you can see that the stop words have been removed. If I compare this with the tokens, you see there are the, is, and has. These extra words which does not mean anything actually are removed in this step using the stop word removal technique. However, in our case, as the context is important to understand the meaning of the review, we will not be removing the stop words. This was just an example of what all techniques, pre-processing techniques, are essential for any NLP task. This basically concludes the pre-processing required for our project. Although the process may be simple and straightforward to you guys, it's a crucial step that shouldn't be underestimated. Proper data pre-processing can significantly enhance the efficiency and effectiveness of our models, laying a solid foundation for the more complex analysis and tasks that follow. And like always, you can access this code through my GitHub as well, whose link I'll provide in the description. With our data prepped and primed, we are ready to dive into the world of NLP. This is where we teach our computer to understand, interpret, and even feel the text. We will perform sentiment analysis, which is like gauging the mood of a room. We'll assess whether our reviews radiate positivity, negativity, or hang out in neutrality. And then, based on all the reviews and all the sentiments, we will figure out the best product out of all the ones that we have fished. Don't worry, this all what I'm saying right now might seem alien to you, but in the next video, you'll properly understand how we'll be using different models to do sentiment analysis and other NLP tasks. We have journeyed through the world of data preprocessing and got a taste of NLP today. In our next video, we'll venture into the realms of machine learning, where we analyze these reviews using powerful models such as VADER and ROBERTA and find out the best product. Thank you for joining me on this data science journey. If you enjoyed this deep dive into the world of data, hit the like button, share with fellow techies, and subscribe for more data-driven adventures. Keep exploring, and I'll see you in the next video.